Hello everyone, this is a Data 620 final project presentation, and Warner Alexis and I, Mahmud, Hasan, Raji worked on this project. So the project title is Analyzing Social Interaction and Sentiment Dynamics on Twitter. So here is the project overview. So in this project, basically we want to understand how people interact on Twitter and how their emotions appear in these interactions. So basically users mention and tag one another. They create a web of connections while each tweet carries either positive or negative sentiment. We'll then combine network analysis and sentiment analysis to see how user interactions related to emotional tone and whether different communities show different sentiment patterns. Later, we'll link network structure with sentiment to understand how influence group behavior and connection patterns shape the overall tone of conversations on social media like Twitter. So our analysis is divided into three main parts. In part one, we'll discuss about network analysis and we'll perform network analysis. Basically, we'll build a directed mention network to map how users interact on Twitter. We'll identify influential users through centrality measures and use community detection and visualization to understand how conversations are structured. And in part two, we'll analyze text and sentiment, and we will basically analyze the emotional tone and language of tweets by examining sentiment levels, common words, and hashtags. And optionally, we will examine topic patterns to understand how users express themselves. And in part three, we will analyze integrated network and sentiment analysis. Basically, we will combine their both approaches to see whether different communities show different emotional patterns, so whether influential or active users express stronger sentiment, and how sentiment clusters across the social network. So here is the dataset description. Basically, in this analysis, we have used Sentiment 140 dataset, which contains 1.6 million tweets. So the tweets dataset is originally collected through the Twitter API, and it is now available on Kaggle as a CSV file. Here is the link for the Kaggle dataset site. From there, we actually collected the dataset, and the dataset is level for sentiment, where 0 denotes negative and 2 denotes neutral and 4 denotes positive sentiment. So each data includes 6 fields, where the sentiment level is basically the target column or the target data, and the other data columns are tweet ID, date, query flag, user handle, and Twitter text. So this is the part one, network analysis, and at first we have loaded the libraries and the data record for the analysis, and here is the dataset columns or the dataset variables. You see, I already mentioned these column names. So at first we have extracted the all tweets that contained at mentions and bill pairs, showing home mentioned home. So the result basically shows here that we have more than 51,000 user-to-user mentioned links, such as the special one switch foot pair. Basically here the first user mentioned the second user. So these edges form a foundation of the directed mention network. And then we have created a directed graph using network X and added all user-to-user mention edges to it. And after building the graph, we have printed the total number of users and connections, and we have found that the network has nearly 68,000 nodes and more than 47,000 edges. And then we have computed the centrality measures to find out the influential users. So here we have calculated the key centrality measures for the network in degree and out degree to compare mentioned activity more clearly than degree centrality. And then we have computed page rank to identify influential users, and then between centrality to detect bridge users. So for betweenness, we have used the sampling parameter k uh, uh, k equals to 1000 to approximate the values and speed up the computation by sampling only 1000 nodes instead of analyzing the entire network. And then we have determined the top five influential users, uh, and you see that the topmost influential user is Millicyrus, which has a in degree 195 and page rank 0.001470. And the second influential user is Tomac Fly, which has in degree 187 and page rank 0.001282. So they are basically the top five influential users in the network. And then we have detected the communities or the conversational groups, and we have determined the communities. We have found that the network has more than 23,000 communities, and the largest community has more than 1,500 users, and the second largest communities has users of more than 900. So then we have mapped each users or node to a community ID, and if you see the special one user has a community ID of 741, and the switchfoot has the same community ID of 741 as they belong to the same community, and the Meticas and the Kanichan has the same community ID of 3838. And then we have determined top users in each community. If you see the community 0, you see that the community 0 includes UK media personalities like Rusty Rockets, while community 1 is dominated by pop stars such as Miley Cyrus and Didi Lovato, and also, if you see the community 2, community 3, they are all celebrity centered. So I would say that uh, this community is basically a celebrity centered community where the communities basically reflect a Twitter environment mainly driven by celebrity attention, where users cluster around public figures rather than interact with each other. So, and then next we have visualized the network by forming a clear network visuals of top 50 nodes for the clarity. So, and we have found that the communication is primarily directed toward a few highly influential celebrity accounts such as Miley Cyrus, Didi Lovato, Tom McFly, and Peyton Wentz. So they're basically acting as major hubs in the network. So users clusters around these figures, forming distinct, basically fan-based communities with strong internal connections. But they have a little direct interactions between themselves. So this pattern basically demonstrates that information spreads mainly from many individual users toward these central figures rather than between hubs. So overall, basically, the visual highlights the key groups and individuals that shape the conversation and clearly illustrates how attention moves within the network. So here is the visual. If you see the visual, they have formed. This visual has formed like a round shape network where the celebrities they themselves don't have much interaction. Rather, they have created a fan-based communities or networks. So here is the second part. Basically, Warner Alexis will discuss on this text and sentiment analysis, and later I will discuss on the part three, which is basically related to the integrated network and sentiment analysis. So thank you for now.
So hi, good evening. My name is Warner Alexis. So I'm going to talk about part two of our project, which is text and sentiment analysis. So in this part of the project, we focus on text and sentiment analysis. So sentiment analysis is a method used to identify the emotion tone behind a piece of text in our case, which is tweet. So it helps us determine whether users are expressing something positive, negative, or neutral. It gives us insight on how people communicate with emotion across the Twitter platform. So to begin with this analysis, we look at the distribution of sentiment label in our data set. So as we go down to the plot, so each bar represents the number of negative tweets on the left and positive tweet on the right. As you can see, both bars are almost identical in height, showing that we have roughly 800,000 tweets in each category. This equal distribution is ideal for sentiment analysis because it ensures the result are skewed towards one emotional group. So with an even split between positive and negative, we can accurately compare how user express different emotion. So overall, this balanced data set gives us a strong foundation for the sentiment and text-based analysis. So before we can analyze sentiment or build any machine learning model, so we need to clean the raw text because tweet content URL, username, symbols, and a lot of informal language that doesn't contribute to meaningful information for sentiment detection. So the cleaning function you see here, we move length like we move out emotion, keep only letters and standardize everything to lowercase. So this will help our model focus on the actual word user or choosing to express emotion. So in addition to our basic cleaning, so what we do, we also expanded our stop word list by combining standard English word, yes, with Twitter specific filter like lol, Ghana, today, amp. So these high frequency word add noise and doesn't help distinguish between positive and negative sentiment. So by filtering them, we ensure that our analysis highlight the meaningful emotion language in tweet rather than platform specific clutter. So this step is essential because clean, well-processed text lead and much more accurate word frequency analysis, sentiment modeling, and topic extraction later in this topic, in this project. So here we're looking at 20 top word in our tweet. So these words give us immediate sense of the language people use in Twitter. So we notice that a mix of emotional terms like feel, like, sad, wish, sorry, alongside everyday conventional words such as tonight, getting, better, and watching. So these tell us often user express both emotional reaction and daily activity, setting the stage for deeper analysis. So we separate these words into positive and negative tweet. Clearer emotion pattern emerge. Negative tweet focus on frustration, sadness, while positive tweet include terms tied to enjoyment, gratitude, and excitement. So these vocabulary patterns mirror what we later observe in the hashtag analysis. So we create this plot. So when we compare the most common word in negative and positive tweet, so it's interesting. We see a very clear emotion divide in how people express themselves in Twitter. Negative tweets are dominated by words that signal sadness, frustration, unmet expectation. Terms like sad, wish, feel, bad, sorry, and hate. And these words point to emotional discomfort, personal struggle, and disappointment event. So on the other word, Positive tweets show a completely different tone. They feature upbeat, socially engaging words like happy, fun, nice, thanks. So these reflect joy, gratitude, excitement, and friendly interaction. These show how emotional expression on Twitter is not random. Users choose very different vocabulary depending on whether they're expressing a positive or negative sentiment. So what's especially interesting is that these word level pattern perfectly align with the hashtag analysis. Negative twin often include charge of social spheres like fail, I win election, or in a perfect world, imperfect world. So which point out to frustration, social issue, personal challenge. Meanwhile, positive tweet are more likely to include community driven, celebratory hashtag like Follow Friday, Music Calm Days. So what we see is that these patterns are reinforced by hashtag user choice. So negative tweets commonly include tag tied to complaint of serious issues, while positive tweets lean towards community focus and celebratory hashtags. So you have like Follow Friday, like we said before, and then together the word analysis and hashtag tell the same story. We have emotional tone on Twitter is consistent across both language and tagging behavior. So positive and negative conversation naturally separate into instinct, emotion, distinct emotional and thematic space. So to add to what I said earlier, so these graphs at the end of our text analysis, it's a word cloud. So it clearly showed the emotional contrast between negative and positive tweets. So remember, we use the stop word to take off all the words that we didn't need. So what happened now? We have a very good list of negative and both positive word. So in the negative word cloud, the most prominent such as sad, sorry, hate, bad, sick, and which reflect frustration, disappointment, and personal struggle. These words are highlight negative tweet often resolve around unmet expectation, emotional discomfort, daily challenge. So in contrast, so the positive word cloud is dominated by uplifting and social work like awesome, fun, nice, and these terms reflect excitement, gratitude, and friendly. So together, these visualizations make the emotional divide very clear. Negative tweet use language tied to struggle, while positive tweet use language tied to joy, connection, and enthusiasm. So this strong separation between two clouds reinforce the accuracy of our sentiment analysis and demonstrate how emotion naturally shape the vocabulary people choose on Twitter. And thank you. The next part will be conclusion.
So, hello again. This is part three, integrated network plus sentiment analysis. So, in this part, basically we have determined sentiment received by mentioned users. Basically, we have identified top mentioned users with mostly positive sentiment and top mentioned users with mostly negative sentiment. So we have taken a sample for this part, and we have found that most celebrities like such as Tom McFly, Miley Cyrus, Didi Lovato, and Taylor Swift 13, they are associated with mostly negative sentiment, and we did not find much positive. We did not find any positive sentiment related to users in this sample. So this is basically happened due to using a subset. And that subset basically have all mentioned based tweets that are negative. So next we have determined sentiment versus influence matter, And for that, we have calculated the average sentiment expressed by each user and then combined it with their network influence measures. Then we have plotted n degree against average sentiment to see whether users who are mentioned more often also express more positive or negative sentiment in their tweets. So this is the plot, and we have found that most users are mentioned only a few times, and their sentiment scores vary without a clear pattern because we are not seeing here any clear pattern. A very few highly mentioned users appear on the right, and but their sentiment does not show any strong trend again. So this means that user influence does not clearly relate to how positive or negative their own tweets are. And then next we have determined uh, sentiment in the communities, and for that again we have plotted the sentiment distribution for top 5 communities, and to compare the mix of positive and negative tweets in these 5 largest communities. Here, each bar shows what proportion of tweets in that community is positive or negative. So we have found that the communities differ slightly, but overall both positive and negative tweets appear in every group. So this helps us to understand the basic emotional patterns within each community. And then we have determined hashtags by sentiment in one community. Basically, we have selected the largest community for this part, and we examined the hashtags used in its negative and positive tweets separately. And then we have listed the top hashtags for each sentiment to see which topics are linked to negative expression and which ones appear more in positive conversations within the same community. So here are the list. If you see the top hashtags in negative tweets in the largest communities, we have found that the top hashtags which is related to negative which are related to negative tweets. They are basically follow Friday, Crystal, Twitter take over, fail. So these are the hashtags. And the top hashtags in positive tweets, we have found that follow Friday, and then noun dies Sunday, Twitter take over, maternal health, etc. So this basically shows that different types of topics are linked with negative and positive sentiment inside the same community. So the next part is the conclusion part, and Warner Alexis again talk on this. So thank you for all to listening to me. Thank you so much again.
So Mahmud did a good job of talking about that part one and part three, which show us our network analysis. So to conclude, we the result of our analysis demonstrate that we successfully achieved the project goal by uncovering how sentiment and user interaction patterns shape conversation on Twitter. Though network analysis, we identify meaningful structural pattern, including influential user and distinct community that guide how information spread across platform. Our sentiment analysis reveals strong difference in the language, topic, and emotional tone associated with positive and negative tweet, illustrating how users express themselves differently depending on context. So beyond the analytical result, this project was genuinely fun learning experience. So taking this class allowed me to explore new method, especially network analysis, which I found engaging and rewarding. I truly enjoy experimenting with how user interaction form complex structure and uncovering the deeper insight that emerge when network analysis combined with sentiment analysis. So to go back to that, so by integrating on our approach, both approach, we show that sentiment and network structure are closely connected. So influential user tended to receive more negative label mention. Community display unique mix of emotion expression, and certain hashtag align with specific emotion team. So together, finding highlight that conversation on Twitter are shaped not only by who interact with one, but also how they express emotion. So, in summary, our combined network and sentiment analysis provides strong evidence that emotional tone is deeply intertwined with user interaction pattern and community dynamic on Twitter. This integrated perspective confirmed that our approach effectively met the objectives of the project and offer valuable insight on how discussion form, evolve, and cluster across social media. Thank you, guys.